Let us begin carbon compounds. What is meant by carbon compounds? In a compound, if there is carbon, then we can say that that compound is a carbon compound. There are large number of carbon compounds. Here few examples we will study, which are CO2, carbon dioxide, CO, carbon monoxide, then we can say that CH4, methane, CS2, that is carbon disulfide, CaCO3, calcium carbonate, then sodium carbonate. So here all you can see that carbon, C means carbon. So all these compounds are the examples of carbon compounds. Now there are two types of carbon compounds. One is known as organic carbon compounds, other one is known as inorganic carbon compounds. So carbon compounds itself is of two types. One is known as organic carbon compounds, other one is known as inorganic carbon compounds. Now organic carbon compounds, for that few examples we will study, that is methane, ethane, C2H6, propane, C3H8. Then we can say as glucose, or we can say as carbohydrates, then proteins, then fats or lipids I am writing here, then nucleic acids, DNA, RNA we can say. These all are the examples of organic carbon compounds. Now here inorganic carbon compounds, for that examples carbon dioxide, carbon monoxide, then carbides, then we can say as carbonates, etc. So here now carbon dioxide, carbon monoxide, carbide will be there, only C will be there, carbonate will be there, then CO3 will be there. Now these all are the examples of inorganic carbon compounds. Now what is the difference between organic carbon compounds as well as inorganic carbon compounds? In organic carbon compounds, carbon as well as hydrogen will be the essential elements, we can say. Carbon, along with carbon there will be hydrogen. Here again carbon along with carbon, hydrogen will be there. Here again in all cases we can say that along with carbon, hydrogen anyhow will be there. Now even nitrogen can be, oxygen can be, but compulsorily carbon as well as hydrogen will be there. Then we can say that organic carbon compounds. Now inorganic carbon compound will be there. There will be carbon, but along with that oxygen will be there, or carbon alone will be there. So such type of compounds we can say as inorganic carbon compounds. Now what is meant by inorganic compounds? Now compounds, only compounds, if we say compounds itself is of two types. Now if we are saying about the compounds, compounds are of two types. We can say as organic compounds as well as inorganic compounds. So here now compounds are of two types, organic compounds as well as inorganic compounds. Now organic compounds, there will be an essential element, that is carbon as an essential element. At the same time, inorganic compounds, an essential element, that will be a type of metal. So here now compounds are of two types, organic compounds as well as inorganic compounds. In organic compounds, carbon will be the essential element. At the same time, inorganic compounds, there will be a metal as an essential element. Now here organic compound we will study as, here we have already studied, that is organic carbon compounds. Carbon as an essential element we had studied, along with that hydrogen will be there, or hydrogen as well as oxygen can be, or carbon, hydrogen, oxygen as well as nitrogen can be there. So these are the examples of organic compounds. Now these are the examples of carbon compounds only, but here the absence of hydrogen is there. Because of that they are known as inorganic carbon compounds. So here now organic compounds, in that carbon as well as hydrogen will be there. CH4 I written. In case of glucose, if you are writing C6H12O6. Here again you can see that hydrogen as well as carbon is there. Now in case of this one, sugar, if you are saying, or sucrose we can say. So their formula, its formula will be C12H22O11. So here again, this is sucrose or sugar, what we are using at home. This is glucose powder. Its formula C6H12O6. So here we can say that this is carbohydrate, starch we can say. This is the simple form of carbohydrate. This is the complex form of carbohydrate. Now inorganic compounds, for that we can say the example: sodium chloride, potassium chloride, sodium carbonate, NaCO3, potassium carbonate, KCO3. So all these are the examples of inorganic compounds. Inorganic compounds speciality, there will be a metal as an essential element. Then other elements will be there. Here in case of organic compounds, carbon as well as hydrogen will be there. Then we can say that they are the examples of organic compounds. Now we will study in detail about organic compounds. What are the important characteristics of organic compounds? Here there are 6 important characteristics of organic compounds given. First one we'll see what is that. Organic compounds are having low melting point as well as boiling point. So organic compounds speciality, their boiling point as well as melting point is very low, very less. We can say that their boiling point as well as melting point will be below 300 degrees Celsius. It can be below 300 degree Celsius. Now, organic compounds can form covalent bonds. They have no capacity to give as well as take electrons. They can just share electrons of other atoms. They are not having the capacity to give electrons as well as take electrons. They can just share electrons with other atoms. Then they are the bad conductors of electricity and low conductors of heat. Now, carbon is the essential element, important element in the organic compounds. This carbon can bond with other carbon or oxygen or nitrogen or hydrogen. These organic compounds cannot form ions. In case of ionic compounds, they can form ions. For example, Sodium chloride is an example of ionic compound. It can form sodium ion as well as chloride ion. We can say that Na plus ion as well as Cl minus ion. Such a way, ions formation is not possible with organic compounds. Organic compounds can share electrons, but they never give electrons to the other atoms, or they cannot take electrons from other atoms. In case of ionic compound, for example, sodium chloride, its electronic configuration 281, chlorine, its electronic configuration. This is now sodium ion. So already sodium ion is formed by giving away one electron. That means a valence electron of sodium atom to chlorine atom. So here I am writing now electronic configuration of chlorine atom 287. Now by taking one electron from sodium atom, here so chloride ion is forming. Now chloride ion, its electronic configuration will be 288. Here now by losing one electron, sodium ion, its electronic configuration will be 2,8. This one electron gone to this chlorine atom. As a result of it, it became one minus ion, it became a positive ion. So positive ion as well as negative ion or ions formation is possible only with ionic compounds. Ionic compounds. Ionic compounds can form ionic bonds, or we can say ionic compounds are forming ionic bonds. Organic compounds are forming covalent bonds. Now organic compound we can call in other name, that is covalent compounds. Organic compounds we can call as covalent compounds. Covalent compounds can form covalent bonds. Ionic compounds can form ionic bonds. Here, essential element present in the organic compound, that is carbon. In case of ionic compounds, essential element that will be a type of or a metal. Any metal we can say. Sodium can be, lithium can be, potassium can be, like that way any metal can be there. So metal should be there in the ionic compounds. Along with the metal, one non-metal also will be there. In case of covalent compounds, which all elements are present in the covalent compound or organic compound, all will be non-metals. Atomic number of carbon is 6 and its mass number is 12. So carbon has atomic number 6, mass number 12. Its electronic configuration is 2,4. Its outermost orbit has 4 electrons. It can become octet condition by receiving 4 electrons from other atom, or it can become duplet condition by removing its outermost electrons. But giving 4 as well as taking 4 is very difficult in case of carbon. So it does sharing of electrons with other atoms. Now if it can remove 4 electrons from its outermost orbit, it can become nearest noble gas, that is like helium. If it can remove this outermost electron, it can become the electronic configuration as nearest noble gas helium. Helium, it has only 2 atomic number, so its electronic configuration is 2. These 4 electrons, if it can remove, its also electronic configuration will be 2. Then it can be like helium. Or if it receives 4 electrons from any other atom, it can be the noble gas like neon. Its atomic number is 10, mass number 20. Then it is having the electronic configuration 2, 8. Neon has electronic configuration 2, 8. If carbon can receive 4 electrons from any other atom, it will also have the electronic configuration like neon. Even neon is an example of noble gas. But here 4 electrons giving or 4 electrons receiving is very big task to the carbon. As a result of it, it never give 4 electrons to any other atom, or it never take 4 electrons from other atom. As a result of it, it share 4 electrons from other atoms. So sharing process is happening in case of carbon. As a result of it, it can form single bond, double bond as well as triple bond with other atoms. Now we will study in detail about how single bond formation, double bond formation, triple bond formation takes place. How single bond formation is taking place, we will see now. First we will take hydrogen. Hydrogen molecule H2. 2 hydrogen atoms combined together, hydrogen molecule is formed. Now how the covalent compound formation is taking place with hydrogen, we will see. Hydrogen 1, again one more hydrogen I am writing here. And now here one hydrogen atom, this is its nucleus, this is one electron present in it. Here this is the atomic number of hydrogen, so it has 1 electron, mass number 1, here atomic number 1, mass number 1, this is the number of electron. Here nucleus is there I am not writing now anything, only I written here the number of electrons. Here again one more hydrogen, it has 1 electron as well as 1 proton. So here electron, hydrogens, here again 1 electron. Hydrogen has atomic number 1, it has 1 electron, hydrogen has 1 atomic number, it has 1 electron. Now both of them join together, hydrogen molecule is forming. How they are joining, that I will show you. Here one hydrogen, again one more hydrogen, they just overlap with each other. Overlap means just they share with each other. Now this hydrogen, its electron, here I am making, this hydrogen, its electron I am making here. They both are just sharing their electrons. As a result of it, if we see about this hydrogen, here I am writing hydrogen, this hydrogen, it has now 2 electrons. If we think of this hydrogen, here I am writing the hydrogen, if we are thinking of this hydrogen, it is having 2 electrons. So like that way, because of the sharing process, we can say that both of them are satisfied with the 2 electrons. So when we are thinking of this hydrogen, it is having duplet condition. When we are thinking of this hydrogen, it is having duplet condition by sharing 1 electron. So this is known as single bond formation. Hydrogen bonded with other hydrogen. This is known as single bond. Now again here The same thing, electron dotted structure. Other name is there, that is electron dotted structure. Such a way also we can be able to mention. Now, representation of hydrogen molecule in an electron dotted structure. That is how we will see. Here hydrogen, saying hydrogen, but this diagram I am not showing, only hydrogen I mentioned. Here again other hydrogen. Now here two electrons are there, that I put like this. So this is known as electron dotted structure of hydrogen. This is the electron dotted structure of hydrogen. So in this case, both of them are shared with one electron, because of that here single bond mentioned. Now similarly, we can represent single bonded structure, double bonded structure as well as triple bonded structure. This is about the hydrogen I shown single bonded structure. Now I am showing you double bond structure with the oxygen. Here oxygen, its atomic number is 8, mass number 16. Its electronic configuration is 2, 6. That means its outermost orbit has 6 electrons. It needs 2 more electrons that takes from or shares from other oxygen. We'll see how it is taking place. This is the outermost orbit of the oxygen. This is its nucleus. First orbit I am not showing, only the second orbit I am showing, because second orbit has how many electrons? They are only taking part in the bond formation. Now outermost orbit has 6 electrons. It needs 2 more electrons to complete its octet. For that 2 more electrons requirement is there, so I am making here 2 electrons. Remaining from this 6 only 2 I made. Now 3, 4, 5, 6 electrons. Now it is sharing with one more oxygen. So this is its nucleus, other oxygen atom, its outermost orbit I made. Now here 2, here again I am making 2 electrons, because same electronic configuration, 2 requirement of 2 electrons are required to this oxygen also. So 2 I made here, 3, 4, 5, 6. Now as a result of sharing of electrons between these 2 oxygens, here you can find the overlapping of 2 oxygen atoms. This is one oxygen, this is the other oxygen atom. This oxygen atom, its outermost orbit has 6 electrons, but 2 requirement is there, so sharing of 2 electrons are taking place. So this oxygen atom giving 2 electrons to this oxygen atom, and this oxygen atom giving 2 electrons or sharing 2 electrons with this oxygen atom. Now 2 already I written, 3, 4, 5, 6. Here 2 written, 3, 4, 5, 6. Now we can say that here sharing of these 2 electrons took place here. So as a result of it, we can say that oxygen bonded with 2 electrons bonding took place. Because of that, here we can say that oxygen bonded 2 electrons with other oxygen. So we can say that this is the double bond formation. Double bond formation. So here now oxygen, its outermost orbit has 6 electrons, and this oxygen shared 2 electrons from other oxygen. As a result of it, now it became 8. Here total 4 became 5, 6, 7, 8. So we can say that now to this oxygen octet condition became. Similarly, if we count this oxygen already 6 and 2 electrons from this oxygen it is taken. Because of that we can say that this oxygen also in the octet condition and this oxygen also in the octet condition. So this is known as a double bond formation. Now again electron dotted structure also we can show with the oxygen. So here now one oxygen, this is the other oxygen, they both shared 2 electrons, remaining 4 we can show in other place. Similarly here 2 already shown, 3, 4, 5, 6. So this is the electron dotted structure of oxygen. This is the double bond formation, or we can say line bond formation, line we drawn. Here line drawing is there. At the same time here dotted structure is there. So this is the dotted structure, electron dotted structure of oxygen. This is the line bond structure, or we can say double bond structure, double bond formation of oxygen. Now similarly we will study about triple bond formation, how it is taking place. For triple bond structure, I am taking the example of nitrogen, N2. Now nitrogen, its atomic number is 7, mass number 14, electronic configuration 2, 5. Now here I am drawing the outermost orbit of one nitrogen. Here I am making the outermost orbit of other nitrogen. Here this is the nucleus of both the nitrogen. This is nitrogen, this is again nitrogen. Its outermost orbit, inner orbit I am not making, only the outer orbit I am showing you here. Here outermost orbit has 5 electrons. That means it needs 3 more electrons to complete its octet. So for that how much requirement is there? That much electrons I am showing here. 5 already there, then it needs 3 more. Similarly, its outermost orbit has 5, it requires 3 more. That 3 I shown. Now, outermost orbit of one nitrogen has 5 electrons. 3 I already drawn, then I am making here 4 as well as 5. 3 already there, 4 as well as 5 I made. Now, both the nitrogen joined together, nitrogen molecule is becoming. That means one nitrogen overlapping with other nitrogen. Now here this nitrogen's 3 electrons I drawn here. This nitrogen's 3 electrons I drawn here. Now here 3 already over 4 and 5. Here 3 already over 4 as well as 5 electrons. So outermost orbit of this nitrogen has 5 electrons. Outermost orbit of this nitrogen has 5 electrons. This is showing that this is the nitrogen atom, this is other nitrogen atom. Both of them shared with each other, overlapping work took place. As a result of it, now you can find that if we are seeing only about this 6 plus 2, 8. If you are seeing only about this 6 plus 2, 8. So like that way, both of them satisfied with 8 electrons. So we can say that such a way triple bond formation is taking place. Nitrogen shared 3 electrons with the other nitrogen. So such a way triple bond formation is taking place. So here by drawing lines we are making the bond. Now electron dotted structure also we can show, that is here nitrogen, here again nitrogen. It is sharing with the 3 electrons with other nitrogen. Remaining 2 I am showing here. So total 5. Here 2 I am showing, total 5. So nitrogen triple bond nitrogen. Now here we can say that sharing of 3 electrons taking place in between both the nitrogen. So here represented by putting dots. So we are calling it as electron dotted structure of nitrogen. Here triple bond formation. Here with the help of lines we are representing. So this is known as triple bond formation. This is a triple bond formation. So with the help of line we people are representing it. Here with the help of dot we are representing it. So here we can see that line structure of triple bond, here dotted structure of triple bond formation. So this is about nitrogen. Then before we had studied about a single bond formation, that is again electron dotted structure of hydrogen we shown. Double bond structure, for that we studied the example of oxygen. It's a dotted structure also we studied. Here now this is about nitrogen, line triple bond structure we shown, again dotted triple bond structure also we studied. Now we will study single bond structure with methane. Methane, it's a single bond formation, how it is taking place we will study. Methane, its formula is CH4. Methane, its formula CH4. Now here one carbon, this is a carbon, only the outermost orbit is shown, that is sharing with 4 hydrogen, one hydrogen, other hydrogen, other hydrogen and other hydrogen. So here one hydrogen, here other hydrogen, here other hydrogen and here other hydrogen. Now carbon, its outermost orbit has 4 electrons. So here one electron, here other electron, here other electron, here other electron. And this hydrogen, its outermost orbit has 1 electron, hydrogen's outermost orbit has 1 electron, hydrogen's outermost orbit has 1 electron, again this hydrogen's outermost orbit has 1 electron. Now this is the diagrammatic representation of methane molecule. Again we can say that here between carbon and hydrogen single bond, here between carbon and hydrogen has single bond, here between carbon and hydrogen has single bond, between carbon and hydrogen has single bond. So this thing in other way we can write carbon single bond with hydrogen, single bond with hydrogen, single bond with hydrogen and single bond with hydrogen. Now again, so here we can say that line representation is there. We can say that line bond we can see. With the line drawing representation we shown, all these are single bonds. Carbon single bond with hydrogen, carbon single bond with hydrogen, carbon single bond with hydrogen, carbon single bond with hydrogen. Now dotted, how it is, how we can be able to represent it? Dotted structure. Carbon, it has 4 electrons in its outermost orbit. Hydrogen has 1 electron in its outermost orbit. Here again hydrogen has 1 electron in its outermost orbit. So we can say that here again bond formation only, but this is dotted, electron dotted structure we can see. So here now line bond formation is there. Here single bond, here again we can say single electron sharing is there, so single bond, single electron sharing is there, single bond, single electron sharing, single bond, single electron sharing, single bond. So we can say that in a methane molecule, carbon shared with 4 hydrogen atoms with single bond. Everywhere you can find that single bonds. Now I'll explain line structure and electron dotted structure of ethane. The line structure, then here electron bonded structure. Now ethane, its formula C2H6 2C between single bond, then here H6 is there, that means for one carbon 3 hydrogen, here one hydrogen, here one hydrogen, here one hydrogen. Similarly here one hydrogen, here one hydrogen, and here one hydrogen. So here we can say that this is the line structure of ethane. C2 is there, C2. Then H6, here 3, here 3. All are having single bonds. Now here outermost orbit of carbon has 4, 5, 6, 7, 8. Outermost orbit of carbon has 4 electrons, 5, 6, 7, 8. This showing that these lines are showing that carbon is bonding or sharing with one electron of hydrogen, one electron of hydrogen, one electron of carbon, one electron of hydrogen. This carbon is sharing one electron with this carbon, one electron of this hydrogen, one electron of this hydrogen, and one electron of this hydrogen. Now diagrammatically if you are explaining, carbon, its outermost orbit only I am showing, sharing one electron from other carbon. So here overlapping I shown. Here one carbon electron, here one carbon electron. So this carbon atom, its one electron is sharing with this carbon. Here I am showing you carbon, this is again carbon. Here carbon to carbon, carbon to carbon. So here I am making one bond. After that, here 3 electrons, so we can say this carbon is sharing with 3 electrons, one from each carbon. Here again this carbon sharing with 3 hydrogen, one here, and one here. So here now hydrogen, carbon, it's one electron here I shown, remaining total outermost orbit of carbon has 4 electrons. Carbon, its atomic number is 6, mass number 12, electronic configuration 2, 4. So outermost orbit of carbon has 4 electrons. It's one electron I shown here, remaining here 1, 2, 3, then 4. Similarly this carbon, its outermost orbit has 1 electron now I shown, other here 2, 3, 4. So each carbon has 4 electrons in its outermost orbit. Now each hydrogen has 1 electron. One here, one here, one here, one here, one here, and one here. So we can say that carbon and hydrogen sharing of 1 electron, sharing of 1 electron, here again 1 electron, here sharing of 1 electron, sharing of 1 electron, sharing of 1 electron. Now when we are showing electron dotted structure, carbon shared 1 electron with other carbon. So one here electron I shown, here 1 electron shown. Now here 1, here 1, here again 1. That means this carbon shared 1 electron with this carbon. Now here I am showing you hydrogen. Here again I am showing you 1 hydrogen. Here again I am showing you 1 hydrogen. So this carbon shares 1 electron with this carbon, 1 electron with this hydrogen, 1 electron with this hydrogen, 1 electron with this hydrogen. Now this carbon is sharing 1 electron with this hydrogen, 1 electron with this hydrogen, 1 electron with this hydrogen. So this kind of representation is known as electron bonded structure. Line representation will be there, then we are saying as line structure. So this is the line structure of ethane. This is the diagrammatic representation of ethane. This is the electron bonded structure of ethane. Here you can find that everywhere single bond is there. One line you can see here. Similarly here 1 electron bond you can see. 1 electron bond, 1 electron bond. Everywhere one single bond electron you can see. bond formation. So it is known as a single bond formation. Now we will study about how double bond formation is taking place. Now for that one example I am writing, that is C2H4. This is known as ethane. I am writing the spelling here Ethane. Now C2H4 I am writing here as ethene. Ethene. Or we can write it as ethylene. 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 Ethene or ethylene. So here I am drawing the line structure now. Carbon, again carbon. Between two carbon there will be double bond. Here in case of ethene or ethylene, between two carbon there will be a double bond. After that, other place you can see that single bond. Here one hydrogen, here one hydrogen, here again single bond, here hydrogen, here single bond, here one hydrogen. So this is known as a line structure of ethene. Now we are making diagrammatic structure. Here now two carbon. So two carbon, its outermost orbit I am showing you. They are overlapping with each other. Now here double bond is there. So here 2 electron, again 2 electron. This is one carbon atom, this is other carbon atom. Here 2 bond, here now 2 electron pair is shown. After that, here carbon, its outermost orbit has 4 electrons. So 2 already I written here, then 2 more I am making here. So total 4 became. Similarly here already 2 electrons I shown, 2 more. So total 4 electrons in the outermost orbit of each carbon. Now this carbon is sharing with 2 hydrogen. Here one hydrogen, here one hydrogen, 2 hydrogen. Similarly this carbon is sharing with 2 hydrogen, 1 hydrogen, this is the other hydrogen. So here hydrogen, here again hydrogen, here hydrogen, here again hydrogen. Now this hydrogen, so 1 electron I am showing here, this hydrogen's electron here, this hydrogen's electron here, this hydrogen's electron here. Now we can see that here single bond, single bond, single bond, single bond. Why? Because single electron sharing is there, single electron share, single electron share, here again single electron share. But here double electron sharing is there. So here we can say double bond formation between these two carbons. Now we will study the electron dotted structure of ethene. Carbon, again other carbon, between them here 2 pairs. From this carbon 2 electron, from this carbon 2 electron, their sharing is taking place. Afterwards this carbon's 1 electron, this carbon's 1 electron, this carbon's 1 electron, this carbon's 1 electron. So total 4 became, here again 4 became. Here now 1 hydrogen is coming, here now 1 hydrogen, here now 1 hydrogen, here again 1 hydrogen. So we can say that this is the electron dotted structure of ethene. Ethene, E-T-H-E-N-E. So here single bond, here double bond, here single bond, here single bond. So we can say that ethene or ethylene, in that a double bond is there. Carbon to carbon double bond formation is there in ethene molecule. In ethane, carbon to carbon single bond, carbon to carbon single bond. In ethene, this is a ethane, E-T-H-A-N-E. In ethane, carbon to carbon single bond. At the same time, in case of ethene, carbon to carbon double bond. Here also you can see carbon to carbon single bond, here carbon to carbon double bond. This is known as line structure. This is known as electron dotted structure. This is known as diagrammatic structure. Now we will study about triple bond formation. That let us rub out now. Afterwards we will study about acetylene. or we can call it as Ethine. Carbon to carbon triple bond we will study there. Here carbon to carbon triple bond. For that example, C2H2. We can call it as Ethine or acetylene. Ethine or acetylene. C2H2. C2 is there, but between them triple bond will be there. Then there will be one hydrogen here, one hydrogen here. So this is known as a line structure of acetylene, or we can say as ethine. Now here carbon again overlapping with the other carbon. Now 3 electron sharing is taking place. So we can say triple bond formation will take place here. After that only one electron is remaining. Why? Because carbon, its outermost orbit, has 4 electrons, 3 hydrogen here. This is the fourth one. So 4 electrons are present in the outermost orbit of carbon. Similarly here this carbon also having 4 electrons, 3 I already drawn here, 1 I am drawing here. After that here one hydrogen will come, here again one hydrogen will come, here one electron of hydrogen, H I am writing here, here I am writing H, then its electron. So here we can say between carbon, 2 carbon, here 3 bonds you can see. Then carbon and hydrogen, here you can see 1 bond. Here carbon and hydrogen, here again you can see 1 bond. 1 bond here and here 1 bond. So this is the structure, means a diagrammatic representation of ethine or acetylene. Now we will study what is the electron bonded structure of ethine or acetylene. Here now carbon is there, triple bond formation, one more carbon, triple bond formation. That means the 3 electron sharing is taking place, and here we can say carbon, it's 1 electron, and here 1 hydrogen coming and joining or sharing. Here carbon 1 electron, then 1 hydrogen coming here. So here we can say 3 electron pair you can see here, and here 1 electron pair, here again 1 electron pair. This is the electron dotted structure of ethine or acetylene. What are hydrocarbons? Hydrocarbons are compounds which contain only carbon as well as hydrogen. So here hydrocarbons means what? Hydrocarbons are compounds. Hydrocarbons are compounds which contain only carbon as well as hydrogen. In them it's a speciality, they will have only hydrogen as well as carbon. Now hydrocarbons we can divide into 2 categories. So hydrocarbons are divided into 2 categories. One is known as saturated hydrocarbons, other one is known as unsaturated hydrocarbons. There are 2 types of hydrocarbons. One is saturated hydrocarbons, other one is unsaturated hydrocarbons. Now for saturated hydrocarbons, examples: methane, ethane, propane, then fourth one butane. Now you will study 2 or 3 examples only. There are number of saturated hydrocarbons. Now unsaturated hydrocarbons, for that 2 examples only you need to study. One is ethene or we can call it as ethylene. Second one, ethane or acetylene. Now, unsaturated hydrocarbons, if we see, in between carbon, either 2 bonds or 3 bonds will be there. Here now, ethene, in between 2 carbon, you will find 2 bonds. In case of ethane, in between 2 carbon atoms, you will find 3 bonds. Here, in case of all saturated hydrocarbons, in between 2 carbon, there will be only 1 bond. So here we can say that sharing of 1 electron with each other. Here, in between carbon, sharing of 2 electrons. So here 2 pairs will be there. One carbon atom will share 2 electrons to the other carbon atom. When we see here, 1 carbon atom will share 3 electrons to the other carbon atom. So here we can say that here lack of electrons, but here single bond formation is there. One electron sharing only here taking place, but at the same time here you can find that number of hydrogen is less here, even number of hydrogen atoms will be less here. We will compare ethane, C2H6. Here single bond between 2 carbon, afterwards here 3 hydrogen will be there. Now, when we study about ethene, C2H4, here you see from this only ethene formed, but at the same time hydrogen's number is less here. So here because of that carbon to carbon double bond, then hydrogen's number will be less, here only 4 hydrogen. So number of hydrogen is less in case of ethene or ethylene. Now when we come to ethane, there you can see that in between 2 carbon there will be 3 bonds, triple bond will be there. So there again you can find that less of hydrogen, only 1 hydrogen here and 1 hydrogen. We can write the formula as C2H2. This is triple bonded condition. So here lack of more hydrogen we can say. Actually 3 hydrogen should be there, but here only 1 hydrogen you can see. From here this formed as well as this formed. Now here only single bond is there, then it is known as saturated hydrocarbon. Double bond here, triple bond here, to them we are saying as unsaturated hydrocarbons. Unsaturated hydrocarbons. Here between carbon to carbon only single bond is there, so we are saying it as saturated hydrocarbon. Now what is meant by hydrocarbon? Hydrocarbon means it is a compound which containing only carbon as well as hydrogen. Here all the examples, that is methane. Here already examples given, methane. It's a formula I am writing, CH4, methane. Now ethane, it's a formula C2H6. Propane, it's a formula C3H8. Butane, it's a formula C4H10. You can see that all these compounds having only carbon as well as hydrogen. Carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. So we are calling them as hydrocarbons. Hydrocarbons are compounds. They have only carbon as well as hydrogen.